Hello everyone. Today we are going to discuss another coding question asked in Nvidia company. So first we will discuss our problem statement. So yeah, our problem statement is that we have given a linked list and we have to swap the nodes pairwise. So as you can see in the example, our original linked list was 1, 2, 3, 4, 5, 6, and after that null. So we have to reverse pairwise. So one pair is 1 and 2, another is 3 and 4, another one is 5 and 6. So we have to reverse each pair. Right? So 1 and 2 become 2 and 1, 3, 4 becomes 4 and 3, as well as 5, 6, 6, 5. So you can also refer below example. Similarly, here 1, 2 is one pair, 3, 4 is one pair, and here 5 is left with single number only. So we don't have to swap this number. And yeah, so let me explain this with an example. So हमारे पास में एक लिंक लिस्ट है 1, 2, 3, 4 and 5. So हमें we have to reverse like swap pair wise. So 1 and 2 is one pair, 3 and 4 is one pair, and 5 is one pair. So we have to reverse 2, 1, and then 4, 3, and 5. So first, before doing the code, we will discuss what are the base like corner cases. The first case is if our linked list is empty, linked list empty. In that, we don't have to swap it pairwise. If linked list have less than two numbers, like this case, one and then null, so then there is no need of swapping because there is no pair. So to swap pairwise, at least number of nodes should be greater than equal to two. Like in this case, 1, 2, and null. So output would be 2, 1. So this should be the minimum criteria for swapping pairwise node in the linked list. Okay. Now we will discuss different approach to code this solution, this problem. So first solution, we will use iterative method. Iterative. So how our linked list structure is that we have one head pointer. This will point to start of the linked list. Here you can assume data, and then this is next. This next will point to next element of the linked list. Again, data and next. So in the iterative approach, we have one iterator that is pointing to head. And after that, we will keep on traversing our linked list till our head is not equal to null. And then we have to swap this PTR1 data with the next PTR. So what we have to do is swap the data of head with head comma next. So like let's assume 1, 2, 3, and then null. So head is pointing to 1 and head of next is pointing to 2. So what we have to do, we have to swap the data of both the pointers. So after that it will be 2, 1. Okay. And after that, we have to start our head to the next of next. So head equal to head next of next. So it will keep on iterating till the end. And here is one more catch. So we have to break our while loop if our head is equal to pointing to null and head of next is also does not equal to null. And what will be the time complexity of this? So as we are traversing our linked list single time only. So we have to visit n number of nodes. So it's order of n, and we have not used any extra space. So it is space complexity is order of 5. Here you can see the code also. So our method one was the iterative. So we have to start from the head node and traverse the list. While traversing the list, swap the data of each node with the its immediate next node. The time complexity is order of n and space is order of n. So here you can see we have used one temporary pointer and it's pointing to the start of the linked list. And after that, we are iterating our linked list and swapping the data of a node with its immediate next node. And after that, we have initialized our temporary pointer to next of next element. Okay. Okay. So then we will discuss another approach, recursive approach. So in the recursive approach, our base condition would be like if we have less than two number of nodes in a linked list, then there is no need of swapping. So this is the base condition. If there are two or more than two nodes in a linked list, then swap the first two nodes and recursively call for rest of the list. So we will discuss this example also. So let's assume our linked list is 1, 2, 3, 4. So what we will do, so we have one function, recursive function. Inside there, what we will do, we will swap. This is taking one head pointer. Swap the data of head, head next, and after that we will call in the next list. So our next list is 3, 4. Head, next of next. So this is the recursive function. This function is calling itself. Okay. So time complexity in the both the cases, iterative and recursive, both is order of n, and space complexity is order of 1 also because we have not used any extra function call in the stack. So this is the code for the recursive. So our base condition is that if there is at least two node in the linked list, then we have to swap the data, and after that call that same function on the another list, like next of the list. Okay. So this question is asked in Nvidia interview, and you can go through this. So thank you for watching this video. Please like, comment, share, and subscribe this channel. Thank you.